Hi, welcome back. I'm welcoming you all to this beautiful online learning platform, Unacademy. Now we are happy to announce that we started the online training for the students who are appearing for GATE and engineering service examinations. Okay, now about myself, I G Venkata. I have total 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is a VLSI. Now, first we check how to get the Unacademy Learning app into your device. Just go to Play Store, type Unacademy in that, then you get this Unacademy Learning app into your device. It will appear like this. Okay, now just go to Install button, click on this Install button. Okay, at this topmost right corner bottom side, here is a install button. Here is your install button, sir. Now I think so it is visible to you. Now it is visible to you. Just click on that install button. By clicking on that install button, okay, it will install the Unacademy Learning app into your device. Once you open that app in your device, it will shows what are the different courses available in that and who are the top educators handling the different subjects in that. Okay, top educators, they are acting as a faculty to you. Top means, you may ask one thing, sir, what is the meaning of top? Nothing. Top is nothing but they are already well qualified. They are GATE top rankers, IIT toppers, GATE top rank, all India first rank in GATE. I think so, not more than top is there. And IIT topper, all India fourth rank in IES, Indian Engineering Service. These are the toppers, and more experienced faculty also is there. 15 years, 16 years, 10 years, like that experienced faculty are available. So now this is the combination of all these things. Okay, all these faculty are going to handling your subjects. Okay, now just I will show you. See, Tiwari sir, he is the IIT topper. He is the IIT topper. And Ankit Goyal sir, he got 2 times All India first rank in GATE Electrical. And he was awarded President of India Gold Medal in IIT Indore. Okay, he teaches for Electrical and Electronics Engineering. Jaspal Singh sir, he is ex-IAS officer. He is a scientist. Okay, GATE service examination on PSU's topper. Ex-senior Made-Easy faculty he is. Okay, he has more than 12 years of teaching experience. And another top faculty is Sanchit Jain sir. He has more than 8 years of experience. These are the top faculty, and a few more top faculty here I am showing. These are the few more top faculty from different departments. Okay, now we are happy to announce that we are going to start a new batches for mechanical and civil. There is a Ascend batch for GATE 2023 in mechanical engineering. This batch started from 22nd February 2021. Here are the top faculty who are handling the subjects in this. Okay, here are the faculty who are handling the subjects in this. Next, there is a Evolve batch for GATE 2022. This is for mechanical engineering. Here are the same faculty handling the subjects in this. This batch started from 22nd February 2021. And don't forget use my code during subscription, VRAW10. By using this code during subscription VROW10, you get 10% discount. You get 10% discount. Okay. Next, there is a Spark batch for civil engineering. This is for GATE 2022. This batch started from 22nd February 2021. This is the English batch, only English batch it is. Here are the top faculty who are working under this batch. And for mechanical engineers, there is a special mission DDR. Mission DDR is going on. This batch started from 22nd February. The intention about this batch is to provide a good rank to the students. Okay, now here are the top faculty. Tiwari sir, already I given it his profile. He is the top he is the IIT topper. Uma Maheshwar Rao sir, a well experienced top faculty from the students who are students and faculty from mechanical side who are staying at south side. Sir is a well-known personality in south side. And Meenu Gupta ma'am, Aman Raj sir, here are the few more top faculties. Okay, this team is going to start at the mission DDR. Their intention is to provide a quality data to the students as a complete one mission. You need to, they started the mechanical batch. Okay, their intention is to provide the top ranks to the students who are under this batch. And there is a Ascend batch for GATE 2023 for civil engineering. Okay, here are the faculty working under this team. So Gil sir, he is the top educator, and Jaspal Singh sir, already I told about him. He got All India 4th rank. Okay, and it is this batch started from 8th February 2021. 8th February 2021. Okay, next one is now there is a Eval batch for GATE 2022 for civil engineering. Okay, this batch started from 8th February 2021. The same team who taken the classes for GATE 2023, same team is going to handling the classes here also. And don't forget to use my code VROW10 during subscription to get 10% discount. And there is a Eval batch for GATE 2022 for computer science and information technology. Sanchit Jain sir, already I explained about him. He is the top faculty in computer science. And this batch started from 8th February 2021. Here are Barao sir, okay, Malesham sir, so Shweta ma'am, Goti sir, like this. Different top faculty are available, and Ravindra Babu sir, okay, like that. Now there is a Ascend batch for GATE 2023 in electrical department side. This is the team. You observed or not, compared to remaining departments, electrical department team is a lengthy because power systems and different subjects are there for them. Okay, the high-end subject is a power systems according to my knowledge. Okay, now that's why lengthy subjects, so lengthy team. Okay, each faculty have their own specialization. They will cover those specializations. And this batch started from 1st February 2021. Now there is a Ascend batch for GATE 2023. This is for electronics and communication engineering. So here are the team who is working under this. Okay, this batch started from 1st February 2021. And don't forget to use my code VROW10 during subscription to get 10% discount. VROW10 to get 10% discount. Next, there is a Eval batch for GATE 2022. This time this is for electrical, and this batch also started from 1st February 2021. Okay, now the same team, the team which was handled GATE 2023, same team is going to handling 2022 also. And for electronics and communication also there is a Eval batch for GATE 2022. Okay, this batch started from 1st February 2021. So this is the team which is handling the subjects in this. And now we are moving to last department, chemical engineering department. Now this is there is a Eval batch for GATE 2022 So here are the top faculty who are handling these subjects in chemical engineering, and this batch started from 25th January 2021. And one more important thing I am telling, sir, if any of your friends are in this background, please inform them. Okay, please inform them, because it is very difficult at outside to get the chemical engineering side, chemical engineering classes. Okay, I think so throughout India, hardly one or two locations are there. Hardly one or two locations, not more than. Okay, so to provide a for them, for the people who try to taking the training for this chemical engineering, they need to travel that locations. Practically it is very difficult who are staying far from that location. Okay, so for them they started this batch. So they must thank to Unacademy to provide such a beautiful facility to the people. Okay, they brought everything to their hands. Okay, everything in their hands. So you have a mobile or laptop, just to see, use that one. You get everything in front of you. They brought everything in front of you. Okay, so please select the appropriate batch and join in that. Now just we go back and we glance what are the different departments available, engineering departments: mechanical engineering, electrical engineering, civil engineering, production and industrial, instrumentation engineering, computer science and IT departments, and chemical engineering, and last but not least ECE, electronics and communication engineering. Electronics and communication engineering. Okay, next. There is a here there are two subscriptions. First one is a plus subscription, second one is iconic subscription. Plus subscription is the basic plan. Iconic subscription is take your GATE preparation to the next level by providing a personal coach to you. Here in first three, India's best educators are going to handle your classes. There are interactive live sessions are there, structured courses and PDFs are available, and live tests and quizzes are there. Here we are going to differentiate from plus to iconic. In iconic team batch, we are providing a personal coach to each and every individual students. Please note down this, not for a batch, individual. For individual student we are providing personal coach. Okay, now the duty of that coach is he will analyze the exam paper what you written. From that he will take the points where you are strong, okay, where you are committing mistakes, and where you are need more preparation, in which topic you need more classes you need to attend, more work you need to do. Everything they will prepare, and based on that analysis they will prepare a proper study planner to respect to student, and respect to material they will forward to that student. So once they provide this much beautiful facility to the students, every student will success in their career. All these things are designed based on the already in our team we have all successful peoples are in our team. GATE first rank, all India top rank, all India IES, all India fourth rank, gold medalist from IIT. All these are toppers. Based on their experience, already they traveled in that path. They know the hurdles in that path. Based on their experience, their knowledge, okay, they designed the structure. Okay, so already they got success by following this structure. So they are implementing the same structure for the remaining students to get the success in their lives also. Okay, please my dear students, please think once of it. Discuss with your friends, your family, your parents, and your colleagues, your friends, your teachers who are having knowledge on GATE and service examinations. Okay, and understand the outside situation. I don't know, and recently yesterday I listened in news, few of the states are again going to lockdown. Now the outside situation is not good. Okay, please think once of it and take a good decision. Okay, definitely you will success in your career. Okay, Now, if you observe the cost of this plan and this plan, that is a reasonable one. For plus plan, it is available in 1 month subscription, 3 month subscription, 6 month subscription, 1 year subscription, 1.5 year subscription, and 2 year subscription. As a faculty, I recommend the students to take minimum 1 year subscription. The cost of 1 year subscription is 30,250. By using my code VRAW10 during subscription, you get it by 10% discount. It is at 27,225 rupees. 27,225 rupees. You get it by that amount. And for example, at outside you joined somewhere for training offline for 1 year. To travel throughout the year in weekdays, in weekends and public holidays, to travel from your home to that location and return back throughout the year, its cost is more than 20,000. Okay, cost is more than 20,000. Okay, so just by adding 3 to 4,000 to that, just by adding 3 to 4,000 to that, you get the training for that. So you are getting more benefits compared to that. So my dear students, please think once of and take a right decision and be at right position. Okay, and we move to iconic plan. In iconic plan, we have two subscriptions, 12-month subscription and 24-month subscription. So it is a 1 year subscription. Okay, and 2 year subscription. This is a 74,000. 1 year subscription is 50,250 rupees. So by using my code VRAW10 during subscription, you get it by 25,225 rupees. See, you observed or not, most of the classes, most of the subjects, most of the classes we are providing online by free to all the students, and we are charging this amount just for guidance. We are placing one coach to each and every individual student. He has to take care about that student throughout the year. Okay, what subject he is preparing this week, how much topics he covered, how much topics covered in class, how much topic preparation completed by the student, topic wise the student is written the exams or not, how many exams they've written, what is his performance, where student is doing mistake. Okay, students are satisfied about the classes, or student is satisfied about their performance in the examination or not, if not, what is the reason, where is the gap, everything is going to be taken care by your personal coach. Once that much care they are taking about us, then what we need, definitely 200% we get success in our career, in our examinations. So my dear students, please think once of it, take the right decision. Thank you. Now we move to our topic. Our topic is a concept through problems on PN-Junction Diode. Already we solved few problems on this, few problems are left in this. So directly I am going to taking you to that problems where we are left. So these are solved problems. Already we solved all these problems. So this is the last problem we solved. This is the last problem we solved. Okay, now I'm going to start from the next problem. Say this. So the next problem is a silicon PN junction diode under reverse bias has a depletion region width 10 micrometer. So depletion region width is 10 micrometer. Fine. So the relative permittivity of silicon epsilon r 11.7 and permittivity of free space 0.85 into 10 power minus 12 farad per meter. The depletion capacitance of the diode per square meter. That means we know the junction capacitance. We are writing it as epsilon A by D. D means depletion with W. So they want Cj per A is how much? From this we can write this one is epsilon by W. They are asking per square meter. You observed or not? Per square meter. It should be in meters. So epsilon should be in meters, W should be in meters. Now it is 10 into 10 power minus 6 meters. So it is 10 power minus 5 meters W value. Next, epsilon value you observed, epsilon naught into epsilon r, already we solved it. It is 1.03 into 10 power minus 12 farad per centimeter. Okay, in farad per meters, it is approximate value is 10 power minus 12. It is farad per, in centimeters, meters it is 10 power minus 2 meters. Now it is 10 power minus 10 farad per meter. Just take that values, substitute here. Epsilon is 10 power minus 10 by 10 power minus 10 farad per meter. This is important, sir. And W is 10 power minus 5 meters, which is 10 power minus 5 farads per meter square. Okay, but they given of the order of microfarads. Now by 10 into 10, it is a 10 microfarads. 10 microfarads. Simple. Just add, divide with 10 and multiply with 10. Okay, 10 microfarads. So this is the option. This is the option. So there is a chance of committing mistakes here, sir. So be careful. Be careful. Because generally everything we are just taking in terms of the order of centimeters in terms of units. So as usual, students also try to go for convert everything in terms of centimeters and do it. There is a chance of committing mistake. Please be careful. So the next one is, see, consider an abrupt PN junction. Let VBI be the built-in potential of the junction and VR be the applied reverse voltage. Fine. So VBI is nothing but we are calling it as contact potential, sir. This is the applied reverse voltage, reverse bias voltage. If the junction capacitance CJ is 1 picofarad for VBI plus VR equals to 1 volt, then for VBI plus VR equals to 4 volts, junction capacitance will be, see, we know the equation for depletion region under reverse bias. Depletion region width is square root of 2 epsilon by q into 1 by NA plus 1 by ND into V0 plus VR, and that means W is directly proportional to square root of V0 plus VR. At the same time, junction capacitance is epsilon A by W. It means CJ is inversely proportional to W. So W directly proportional to this, CJ inversely proportional to this. By combining these two, you can propose CJ is inversely proportional to square root of V0 plus VR. So now we can write CJ1 by CJ2 is square root of inversely square root of V0 plus VR2 second case by square root of V0 plus first case VR1. Substitute the values. Square root of V0 plus VR2, this is the second case, 4 volts, by first case square root of 1 volt. This is 2 simply. Now we need CJ2. CJ2 is CJ1 by 2. CJ1 they given 1 picofarad by 2. It is 0.5 picofarads. 0.5 picofarads. So this is the option. Okay, so like this you need to get the direct formulas. Sometimes are not available, sir. Whatever the different formulas we have, from that you need to construct the required formula. Okay, by constructing that you can easily get the solutions. See next one. So the same problem, sorry it was repeated, I'm very sorry for that. Next one, the doping concentration on p side and n side of silicon is this much. On p side means it is a Na and it is Nd respectively. P side and n side, Na and fine. A forward bias of 0.3 volts they are applying. Forward voltage means diode voltage. VD, we called it either forward voltage, anyone you can call it, by 0.3 volts at room temperature. The intrinsic carrier Ni value they given 1.5 into 10 power 10 per centimeter cube. KT by Q 26 millivolts. KT by Q, also we called it as VT. Yeah, it is at 26 millivolts. Fine. The electron concentration at the edge of the depletion region on p side is, okay, what they want is, so already we done all this. Now let us take, this is our PN junction. So just assume a small negligible depletion region at junction. Let us consider it as N region and P region, and there is a steady state, under steady state minority electrons are available here. We called it NP naught. Once it is forward bias, that means N is negative, P is positive. More number of electrons are entered from this region to this region. More number of charge carriers are entered. Okay, let us take this much number of charge carriers are entered into this region. This much charge carriers are entered at the junction. Already few charge carriers are available here. These are the existing charge carriers under steady state. Okay, now more number of electrons, less number of electrons. Now there is a diffusion takes place. Now these carriers are diffused like this. The diffusion is like this. Yeah, yes. Now these are called excess or injected charge carriers. Already we done all this analysis during the derivation of diode equation. Now this value is, let us take the injected charge carriers at junction is N dash of 0. Now its value is N dash of 0 into e power minus x by Ln. Ln is the diffusion length of electrons in p region. Okay, that is the equation. Now total value of this one is, total electron concentration at junction is, it is NP naught plus N dash of 0 into e power minus x by Ln. This is the equation. Okay, now once you know this equation, but we need, what do you want, the electron concentration at edge of depletion region. At edge of depletion region means this one, at junction, close to junction. Okay, at this point they want, and compared to this value, amount of injection what is taken place here, this is very small value. Okay, anyway, already we derived this one from characteristics of VI voltage current relation. Okay, from diode current, in diode current equation derivation we analyzed that. Now that amount of charge injected is, okay, electron concentration at edge of the depletion region. So I am calling it as N, okay, N P of 0 at a junction. Electrons concentration in P region at a junction equals to NP naught under steady state concentration into electron concentration into e power applied forward voltage Vd by V naught. Sorry, it is Vt, sir, not V naught, it is Vt. Vd by Vt minus 1. This is the standard equation. We derived this equation during the diode current equation, like this process. Now NP naught value is simply, by mass action law, it is Ni square by electron concentration in P region, it is Ni square by Na. And they given Vd value 0.3 volts. We know the Vt value 26 millivolts. Just substitute the values in that. Therefore NP naught is, so its value is Ni square 1.5 into 10 power 10 into 1.5 into 10 power 10 by Na is 10 power 16. So it is 20, it is 16, 10 power 4 it is. 1.5 into 1.5, it is 2.25 into 10 power 4 per centimeter cube. Yeah. So now it is 2.25 into 10 power 4 into e power Vd. E power Vd is 0.3 volts. I am taking this one in terms of millivolts, 300 millivolts. 300 millivolts by Vt is 26 milli. Okay, 26 minus 1. Just simplify that. So 300 divided by 26. So we need e power of that. E power that. It is 1 into 10 power 5. Its value 1 into 10 power 5 approximately. So 2.25 into 10 power 4 into 1 into 10 power 5. Okay, 1 into 10 power 5. So it is per centimeter cube. So now it is 3, 4, 5. Yeah, it's correct. Now 2.25 into 10 power 9 per centimeter. Okay, so now the per centimeter cube they are asking. See, 2.25 into 10 power 9, 2.25 into 10 power 6, 1 into 10 power 17, 1 into 10 power 16, 2.3 into 10 power 9. So you can take 2.23 approximately 2.3 into 10 power 9 per centimeter, approximate value. So the option is A. A is the correct option. So it was asked in previous GATE examination for 2 marks, sir. See, the intention behind during the analysis of PN-Junction diode, there I derived complete diode current equation, and at every level where is the possibility of getting the question, and that equation I highlighted, okay, and I will kept it in a box. Okay, so please, my dear students, please go and check each and every equation which is available in that. Every equation is important, and please don't feel that we don't want derivations. Don't think like that. Every derivation try to derive and get the concept which is involved in that. When you are strong with the concepts, you can easily solve it. Okay, for example, you forgot the concept, you forgot the equation, then immediately go to the analysis like this. Okay, once you done some process, then automatically you get the equation. Okay, so please go through concept and try to practice every derivation. Okay, thank you. Now we are moving to the next problem. See, consider an ideal silicon PN junction. It is a silicon junction, sir. Na 10 power 18 per centimeter cube and Nd 10 power 16 per centimeter cube. The layout area of diode is 10 power minus 4 centimeter square. Calculate the junction capacitance, depletion capacitance at T equals to 300 Kelvin. Assume Ni 10 power 10 per centimeter cube and dielectric constant of silicon is 11.8. Sir, they want junction capacitance. So junction capacitance, we know it is under open circuit. They did not use any term related to biasing. So Cj naught they want. That is, we know that epsilon A by W naught. Okay, they given epsilon. We know epsilon value. It is 10 power minus 12 farad per centimeter. Area they given 10 power minus 4. Now we need to get W naught. And this is the equation for W naught. Already we derived in previous problems also. We used it. 2 epsilon by Q into 1 by Na plus 1 by Nd into V naught. So first we need to get the V naught value. V naught is Vt into ln of Na Nd by Ni square. Okay, these are the equations. First I am going to calculating the V naught value. Okay, so first V naught is Vt, we know that 0.026 into ln of Na Ni. So Na is 10 power 18, Nd is 10 power 16 by Ni square 10 power 10 into 10 power 10. So simplification is 10 power 10, 10 power 10, 10 power 20. Now it is 10 power 14. Ln of 10 power 14. Simple it is 0.026 into ln of 10 power 14 is 0.026 into 14 into ln of 10 is 2.3. So that is the volts. Now I am simplifying that. 0.026 into 14 into 2.3, that is 0.83 volts, 7 volts. That is V naught. Immediately I am going to W naught. So W naught is square root of 2 epsilon by Q, 2 into epsilon 10 power minus 12 by Q, 1.6 into 10 power minus 12. Sorry, 10 power minus 16 because we are writing Q value. Sorry. 1 point Q charge 1.6 into 10 power minus 19 into 1 by Na, so 10 power 18 plus 1 by Nd 10 power 16 into V naught 0.837. Yeah, see this, sir, simple it is. 2 it is 0.8 times. Now take 10 power 16 common. Now it became 1 by 100, 0.01, 1.01. So it is square root of 1.01 into 0.837 by 0.8 into 1 by 10 power minus 19 into 1 by 10 power 16. That is the value. Simplify this. So it is 10 power 3. Okay, now approximately it cancelled in this by 0.1 times. Okay, I will simplify that. 1.01 into 0.837 divided by 0.8 into 1000, square root of that value. So it is a 32.5. 32.5. Yes. So sorry sir, and one more thing we have, okay, 19 taken, but 10 power minus 12 is there. I am taking this 1 to 10 power minus 6. Okay, so this is in centimeters. So that is 32.5 into 10 power minus 6 centimeters. Okay, no need to convert micro, later we check it. Now I am going to calculating the value of Cj. Cj is epsilon A by W naught. Epsilon is 10 power minus 12 into area 10 power minus 4 by W 32.5 into 10 power minus 6. Just simplify. Okay, 6 it is 10 power minus 6, 10 power minus 10, 1 by 32.5 divided by 32.5, it is 30.7 into 10 power minus 3, okay, and into 10 power minus 10. So this is a 3.07 picofarads. 3.07 picofarads. So this is the closest value. Okay, because after decimal I am going to leaving taking only 2 digits, third digit, fourth digit if you consider, then you get the exact value. Okay, but in examination they will give that much concession to you, no need to worry about that. Okay, so this is a nice problem because we need to, but seems to be a simple one, only Cj calculation, but in that V naught is involved as well as W naught also involved. Okay, so consider the charge profile shown in figure. The resultant potential distribution is best described by, so this is the rho V, charge profile rho V, and described by, it is best described by this plot. Already we discussed this one under PN-Junction Diode. Different plots there we have, there we discuss it. It is constant from this point. But in this one, this is decreasing to 0. No, at junction it is 0. Sudden discontinuity, it is not taking like this, because we have an equation E is equals to minus dV by dx. From this, V is integral minus integral V into E into dx. But E is the linear one. Integral of linear means integral x is x square by 2. It is a parabola. So this is the parabola. Okay, and it continues. It is constant from this point. It is parabola, but it is suddenly decreases to 0. That's why it is not this one. But in this case, so not this one because of that. And in this case, at a junction it is 0, so that's why it is not. It is also not. This is the right one. That's it. Yeah, now we are moving to the next one. A germanium diode has a reverse saturation current of 30 microamps at 120 degrees centigrade. Yeah, generally the temperature we are using is a room temperature, but in this case they are using the saturation current at 120 degrees centigrade. Clearly they are saying the temperature. Now see here, reverse saturation current they given 30 microamps at a temperature of 120 degrees centigrade. First calculate Vt. We know Vt is kT by Q, is T by 11,600. Just by substituting the values of K and Q in that, you get that. So T value is 273 plus the temperature 120 watt they given by 11600. Simplify that. 273 plus 120 equals to divided by 11600. That is 33.8 millivolts. 33.8 millivolts. This is I naught, fine. So what they want? Now they want a dynamic forward and a dynamic reverse resistance. See, dynamic forward resistance already we calculated. It is eta Vt by Id. And dynamic reverse resistance is eta Vt by, in reverse saturation, our current is reverse condition I naught. Eta is 1 for, this is 1 for germanium. This is the Vt value already we calculated. Just to substitute here. Vt 33.8 by I naught, 30 micro, 10 power minus 6 it is, 10 power minus 3 it is, because it is milli. Now 33.8 divided by 30. It is 1.126. 1.126 10 power 3. It is kilo ohms. Kilo ohms. For this, it is Vt. Vt is 33.8 milli by Id. Now we need to calculate the diode current. Okay, now I am calculating the diode current. So diode current Id is approximately reverse saturation current into e power, okay, applied forward voltage by Vt, eta into, because eta is 1 for germanium, it's not an issue. Now it is I naught value given 30 micro, 10 power minus 6 into e power Vd 0.2 volts. So I am taking it as a 200 millivolts by eta is 1 into Vt 33.8 milli. 33.8 milli. Now both will cancel, milli. Now 200 by 30 point, 200 divided by 33.8, it is 5.9. Now I want e power of that, e power that value, it is 371.35, 371. So it is 30 into 10 power minus 6 into 371.35, okay, into 30 again, it is 11.1 milli. 11.1 milli 10 power 3, 11.1, so not, sorry, 11.1 into 3 10 power 3 into 10 power minus 6 amperes. So it is 11.1, approximately 11.1 milliamps. That is ID. Now substitute that one here. Now therefore dynamic forward resistance is 33.8 milli by 11.1 milli. Milli gets cancelled. It is 11.1 milli. 33.8 divided by 1, 11.1. Yeah. So it is 3.04. 3.04 ohms. So you observed one thing or not here, in forward bias the amount of resistance it offered is 3 ohms, and in reverse bias the amount of resistance it offered is kilo ohms. 1.126 kilo ohms. Okay, so that is the important thing you need to identify. 3 ohms means more or less a short circuit, it behaves like on switch, and 1.1 k means compared to this it is 1000 times more, so you can treat this one as a off switch. Okay, so every time you need to compare with on resistance. So the next problem is, see, at 300 Kelvin for a diode current of 1 milliamp, a certain germanium diode requires forward bias of 0.1435 volts. Okay, that means a diode current of is 1 milliamp. For germanium diode, it is taking the voltage across the diode is forward voltage 0.1435 volts. Fine. For the same to get the same diode current, they are using silicon to get the same current by using silicon diode. They are using 0.718 volts. Sorry. So then they want Under the conditions stated above, the closest approximation of ratio of reverse saturation current in germanium diode to that in silicon diode is. See this? From this I am writing 1 milliamp equal to diode current equals to I naught of germanium into e power Vd, applied voltage is 0.1435 by Vt. Vt is 0.026. Okay, theta default take it as 1 by silicon also providing the same current. So I naught of silicon into e power, the voltage is 0.718, 0.718 volts it required, and by 0.026. Now just I am taking the ratio of this because both are equal. This one equals to this one. Now from this we can write. So it is I naught of germanium by I naught of silicon. I naught of silicon is e power 0.1435 divided by 0.026 divided by e power 0.718 divided by 0.026, which is e power, so germanium, sorry sir, it is a it is e power I naught of silicon. I naught of silicon is e power 0.718 by 0.026 divided by e power 0.1435 by 0.026. So it is e power 0.718 minus 0.1435 divided by 0.026. Now this is the ratio. Simplify that. 0.718 minus 0.1435. It is 0.5745 divided by 0.026. It is 22.09. So e power of that value is 3.9 into 10 power 3. Oh, just a minute sir, it is a no, it is a high value you are getting. A minute once again. 0.718 minus 0.1435, it is 0.5745. So e power 0.5745 divided by 0.026 divided by 0.026. It is 22.0. So that is e power 22.06. Now I want e power of that. E power 22 is, so that it is approximately 3.9 into, so some value you are getting more, powers 368. So it is dot, fine. So it is a, so option is not getting. A minute. So one thing sir, you need to consider silicon eta value 2 we consider and we check it. So once you consider 2 for this, 2 for this. Here it is 2. It is 2. Now we check that option. That. So eta is 2 for this. For silicon eta is 2. Now that is point, okay, 2 into 0.1435 is 0.287 minus 0.718. It is 431. So e power 0.431 divided by 0. 0.052. 0.431 divided by 0.052. So 8.28. So e power 8.28. So it is a e power of that. So e power of that, it is 3.9 into 10 power 3. It is a 3977.770 you got. So it is approximately 3.9 into 10 power 3, or you can take approximate value 4 into 10 power 3. So eta is you need to consider, because not that much forward voltage you are applying, very small voltage, and that too diode current is very small value. So for large values of diode current only, eta of silicon taken to be 1. So this is a small value, so you need to consider eta is 2 for silicon. This is the important thing. So eta is 1 for germanium and 2 for silicon. You need to use this one here. So for in all the problems we taken eta is 1, but in this case you need to use eta is 2. Okay, so the problems are like this. So my dear students, please verify each and every problem. Okay, identify the proper solution for that. Now today's session I am going to closing the today's session. So next session we go to the remaining problems. I am thanking to one and all for spending your valuable time with us. Don't forget to use my code VRAW10 during subscription. Okay, by using this code you get the 10% discount, and please subscribe us. By subscribing us you get the notifications, and join our Telegram group to get the latest updates on our upcoming videos. What are the upcoming videos we have? Okay, you get that upcoming videos, and please hit the bell icon for getting the notifications. Please join our YouTube channel and give your valuable comments in YouTube. Okay, so with that comments are the boost to us, and at the same time we will provide a better information to the students who are upcoming, or quality information to these coming students. Okay, so thanks for spending your valuable time with us. Okay, so now once again I am welcoming you all to this beautiful online learning platform, Unacademy. Thank you very much.